Now we have seen the elevation in boiling point is a colligative property. And what is elevation in boiling point? When a non-volatile solute is added to a volatile solvent, the vapor pressure will increase. Vapor pressure will decrease. When vapor pressure decreases, boiling point will increase. That increase in boiling point is called elevation in boiling point, and it is a colligative property. And it is, why it is a colligative property? Because it depends only on the number of particles. And this elevation using elevation in boiling point, delta Tf is equal to, delta Tb is equal to Kb into small w into 1000 divided by capital W into mv. This was our equation, isn't it? We have found out this is delta Tb is equal to Kb into small w into 1000 by capital W into mv. You can use this equation for the calculation of the molecular mass of the unknown solute. Now here what I have written is a numerical based on that. What is the boiling point of an aqueous solution containing 18 gram of glucose in 100 gram of water? 18 gram of glucose in 100 gram of water. You will have to calculate the boiling point of water. Boiling point of an aqueous solution. How will you find out the boiling point of aqueous solution? See, the boiling point will increase when you add a non-volatile solute. So, if you know the boiling point of pure water and the increasing boiling point, you can find out the boiling point of the solution, isn't it? Suppose T0 B is the boiling point of pure water and delta Tb is the elevation in boiling point. Then what is boiling point of solution? It is Ts. It is T0b, the boiling point of pure water plus the elevation in boiling point. You will get the boiling point of the solution, isn't it? So here we know the boiling point of pure water. That what is it? 100 degrees Celsius or 373 Kelvin, isn't it? Now we will have to find out the delta Tb, that is elevation in boiling point. Now what is the formula for delta Tb? Delta Tb is equal to Kb into small w into 1000 divided by capital W into mv. Okay. So Kb, is it given? Yes, Kb of water, that is elevation in molar elevation constant is given. It is 0.52 Kelvin kilogram mole inverse. Now next is small w. What is small w? Weight of solute. Is it given? Yes. 18 gram of glucose is dissolved in 100 gram of water. That is 18 gram. Then what is capital W? That is weight of solvent is equal to 100 gram. That also is given. Then mb. What is mb? Molar mass of the solute. What is molar mass of the solute? It is glucose. What is the formula of glucose? C6H12O6. So that means 6 carbon atoms, that is 12 into 6 plus how many hydrogen? 12 hydrogen. So 1 into 12 plus how many oxygen? 6 oxygen, that is 16 into 6. That is equal to 1272 plus 12 plus 96. 180 gram per mole. That is the molar mass of glucose. Now you substitute. Delta Tb is equal to 0.52 Kelvin kilogram mole inverse. Now the question is per mole, isn't it? This is kilogram, this is gram. You will have a doubt always. So I have seen every time the children converting this gram to kilogram. See, we already converted this gram mole to kilogram. That is why you multiplied with 1000, isn't it? By 1000. And always molar mass we find out in gram. So it is always this to convert this into 1000 in kilogram. We are already divided with 1000. That's why this 1000 came here. So no need to convert this into kilogram because conversion is already done. Then what is small w? Small w is 18 into 1000 divided by into what is capital W? 100 into then MB is 180. Okay. Now, so what is it? This 0.52 Kelvin, kilogram here, gram by this will go. So it is 0.52 Kelvin per mole. For 1 mole it is 0.52 Kelvin. Now we know the T0. What is Ts is equal to T0 boiling point plus delta T. That is T0 is 373 Kelvin. 373 Kelvin plus 0.52. Or you can even use 373.15 because to convert to absolute scale is actually 273.15, or simply you can add also 373. So it is 373 plus 0.52, so it is equal to 373.52 Kelvin. So this is the answer. Okay, so you will have to do it. Similar problems you can take from your textbook and you can do. So this is the numerical based on elevation and boiling point. Even sometimes you can, they ask you, give you delta TB and you can calculate the molar mass of the solute. Same question, or what mass of solute will give any elevation and boiling point of some quantity they will give. It is W, you can calculate. Different types of problems will be given. You will have to do all the different types of numericals given in your textbook. And you take the questions from outside, I will send, you can do it. Now next is the next colligative property. What is the next colligative property? The next colligative property is the depression increasing point. Depression increasing point. Freezing point. Now what is freezing point? See, freezing point is the temperature at which a solid and liquid phase coexist, isn't it? It is the temperature at which a solid and liquid phase coexist. That means the vapor pressure of liquid and solid phase becomes same. Then we call that temperature as the freezing point. Now again, yesterday we have plot the vapor density and temperature. Then you are cooling a solvent, it cools here, and see here, this is the solid phase, and this is the liquid phase of a pure solvent. You are freezing it. So this point is the freezing point of that pure solvent, because at this temperature the liquid phase and the solid phase is coexisting. That means their vapor pressure are the same. Now you take the solution. The solution again we plot. Then here, reaching here, it's solid and liquid phase is coexisting. So this is the freezing point of the solution. Okay. So this is solvent. That is T0 and this is TF, freezing point. And this difference is called depression in freezing point or delta TF. The freezing point is decreasing. Understood? So we plotted the vapor pressure of the solvent first. Then this is the temperature at which is liquid and solid phase is coexisting. That is the freezing point of the pure solvent. Then we plotted that of the solution. We got the freezing point of the solution. The difference between these two is called the depression in freezing point or delta TF. So delta TF is proportional to molality. So they were told as delta TB. The freezing point, depression in freezing point also is proportional to the molality, and delta TF is equal to a constant Kf into molality, and this Kf is called molar depression constant or cryoscopic constant. So delta TF is the depression in freezing point, Kf is called the molar depression constant or cryoscopic constant, and M is the molality. Now delta Kf is equal to delta TF if molality is equal to 1. So we can define the cryoscopic constant or molal depression constant as the depression in freezing point of 1 molal solution. It is the depression in freezing point of 1 molal solution. So delta TF is equal to KF into molality. Delta TF is equal to KF into molality. Now what is molality? Molality is equal to number of moles of solute divided by mass of solvent into 1000. So here itself we have converted gram to kilogram. How will you find out number of moles of solute? Small w, mass of solute by its small r mass. Then mass of solvent, we will take it as capital W into 1000 will give you the molality. So this is the expression for molality. So delta TF is equal to KF into small w into 1000 divided by molar mass of the solute Mb into capital W. This is the expression for the depression in freezing point. And as this is also a colligative property, you can calculate the molecular mass of the unknown solute. That is Mb is equal to Kf into small w into 1000 divided by delta Tf into capital W. So this is delta Tf. So this is the depression in freezing point. So freezing point is the temperature at which the solid and liquid state coexist. So at that point the vapor pressure of the liquid and solid phase will be the same. So if when vapor pressure decreases, this freezing point also will decrease. The decrease in freezing point is called the depression in freezing point. We can find it out graphically. First you plot the vapor pressure of the solvent with the temperature, then vapor pressure of the solution with the temperature, and you can find out the freezing point from the graph, and the difference in freezing point is called a depression in freezing point. And this depression in freezing point is proportional to molality of the solution, or delta TF is equal to KF into molality, or delta TF is equal to KF if molality is equal to 1. That is molal depression constant or cryoscopic constant is the depression in freezing point of 1 molal solution, and delta TF is equal to KF into molality, and molality is small w into 1000 by molar Mb into capital W. You substitute it here, you will get expression for delta TF, and you can find out the molecular mass of the unknown solute by this method. So it is called the expression. Now, so this is the depression in freezing point.